So happy lesson number 5 on Ordinary Simple Annuities. This one will be trying to find out the number of terms in an annuity. So how many payments do we actually have? Now, if you've watched the previous videos with regards to annuities, you know, this concept of trying to solve for an unknown where everything else is given, hopefully is becoming a little bit clearer. So by now you should be able to find out what the future value, what the present value is, what the payments are. And now let's try to knock off how to find your N, okay? The number of payments, number of terms that we are having. So in general, if we do not know how many terms, you can see here that I have designated with N number of terms. And we have basically two formulas, right? So we have a future value formula. So if we know the future value, we know the payments and we know the interest, then we can try to use the future value formula to isolate for that N and then just plug it in. If we know the present value, we know the payments and we know the interest, then again, we can isolate for N, and I've actually shown you here what the equation is. So I have shown the equation right here. It is not very pretty. It uses logs or ln in this case, which is ln. So I want to just first I will take the future value formula and I'm going to isolate for N so that you can see where a formula like this comes from. And then I'm going to leave it to you to try to replicate this present value formula and then isolate it for N. It's basically the exact same process, right? Now, technically, I mean, I don't know, depending where you're studying this. I mean, I doubt that maybe your teachers or profs will make you isolate for this. Because the reality is in business, I mean, we use, you know, our business calculators to do most of the isolations and the work for us, right? So it's the power of these calculators that we have, okay, that we can actually use it. But, I mean, it's still kind of worthwhile to see what if you didn't have these calculators, because once upon a time they were around, and then you would just use basic formulas and use your simple calculators to try to plug these things in. So let me take this particular example, so right here that you see on the left-hand side, so that formula for the future value, and I'm going to do my best to show you how to isolate for that N. Now, the N is in the exponent, and if you're ever trying to solve for an exponent, you know you're going to have to try to utilize logs, right, or ln in this case. So if you haven't been exposed to that, you can let me know in the comments. And I guess if I get enough comments on logs, then maybe I'll do some small videos in the future, and then I'll come back to this one and do a link. All right. But for the time being, I'm assuming that you do have some background in logs and in exponents. Okay, so let's try it. So I'm going to isolate here that future value formula for that N. So first thing that I see, okay, so notice what I have. I have a payment which is outside of the bracket, and then I have my interest which is in the denominator. Now I can get rid of these by simply dividing by payment and then multiplying by the interest I on both sides. So if I do that, so what I'm doing to both sides is the following. So I can take both sides, multiply by N, and divide by the payment, and that will get rid of, so it will get rid of this right here. Now, of course, I have to do that also to the opposite side. Now, if I do it to the opposite side, okay, because it's just a multiplication, then what I will come out with is I will come up with future value divided by the payment and multiplied, okay, so by I. So multiplied by I in the numerator there. And then on the right-hand side, all I'm going to have left is I'm going to have my 1 plus I to the power of N minus 1. So that is simple enough, and you should be able to understand it if you've done some isolation of formulas, okay? So rearranging formulas in particular. So the next thing that I'm going to do is I'm going to take this -1 and I'm going to bring it over to the other side. All right, so if I bring it over to the other side, it becomes positive. So here, let me switch color. So I'm going to have 1 now plus, so future value times my I divided by my payment. And that is equal to now 1 plus I to the n. And here is the problem, because what we're trying to isolate for is this n, which is in the exponent. So the only way to get rid of it is to utilize logs or ln. Okay, so we use either or. So depending what background you have, you can use either log or you can use ln. Now, typically, you'll find these on your calculator. In the business calculator, most of the time it will only have ln. Okay, so that is a special log with where the base is e. Okay, it's Euler's number. Okay, now log typically means its base is 10, and it doesn't matter which one you use. Okay, and since in the business side mostly it's ln, so I'm going to try to stick with that. So I'm going to take the ln or the log, okay, of both sides, of the left-hand side and the right-hand side. And if I do that, so what I'm going to get is I'm going to get a log, okay, of all of this junk. So I'm going to have a log of all of this. So I'm going to copy it, paste it so that you can see where it comes from. All right, so it's going to be log of that is equal to, and now what you have, okay, is you're going to have the log. Let me erase this right here. So you're going to have on the right-hand side, you're going to have a log of 1 plus I. Now this n, because it's in the exponent, that's why we're using this, okay, is going to drop, and that is just a rule that you have for, okay, utilizing logs with exponents. So this is going to come out to n, all right, log of 1 plus I, and here I can copy this, copy that, bring it down, and this is what we have. And now in order to solve for n, so n, I'm going to divide both sides by basically this right here, because it's just a number, log of 1 plus I. Remember, we know I, right? We know the future value and we know the payment. So if we know all of these are just numbers. So now dividing it by on both sides, what you're going to come out to is you're going to come out to n is equal to, let me paste that back because that doesn't change, and divided by, this is going to be divided by, all right, and it's going to be divided by this right here because we were isolating for n. And that would be your actual equation for n. And as I said, so most of the time on the business world, instead of log, I mean, you can use log, most of the time you'll see ln right here. All right, and that would be your entire equation. So there it is. That is your equation if you know your future value, if you know your interest, and you know your payment amount. And then you can find the number of payments or number of terms. So that is right here. Now, if I'm going to scroll back up here, so right here, notice if you had the future value, okay, you would have gotten the equation that I just solved for. But if they gave you the present value and you were doing the solution, this would have been your equation. So notice it looks a little bit different in this case than our other one. So here, this one that you see right there is if you know the future value, and this one is if you know the present value. And that will come out from the actual questions that we will do. All right. So let's take a look at some of these questions and then we can apply these formulas accordingly. All right. Okay, so let me scroll back down here. So here is our question. How many years would it take to accumulate $1 million if investment payments of $1,000 were made each month? So if you're lucky enough to put away $1,000 each month, okay, and you had 10% compounded monthly, then how many years would it take you? So this is a very interesting question. So let's take a look, okay, and see what is given in this example. So let's write it down. So given, so accumulate, so that means future value is equal to $1 million. All right, because we want to accumulate to that. Our payments, so our payments are equal to $1,000, so 1K. Now our interest, okay, so notice our interest is 10% compounded monthly, and our payments, okay, are also $1,000 per month, right? So notice that this is per month and we're compounding monthly. So indeed it is an ordinary simple annuity. All right. So that's what we will make the assumption on. So with that information, you know that your payments per year are equal to the compounding per year, and it's monthly, so it would have been 12. All right, so that means that our interest, I, is, so it's 10% there, so 0.10 divided by 12. All right, so that is coming from there, and those are the numbers that we would actually have right there. All right, perfect. So this is our information, and now let's take a look and see how we can use, okay, our formula. So this, we would be using our formula right here, and we want to be able to solve for n, so copy. Let me bring it down. I'm going to paste it, and that is assuming you're not using a business calculator. You're just using a regular calculator. So let's try to plug all of this in and try to solve for n. So equals, so ln, all right, so open bracket, 1 plus, now it's going to look very ugly because we have all of this junk. So 1 million, this is going to be 1 million, 1, 2, 3, multiplied by our interest. So notice our interest right there is 0.1 or 0.10 divided by 12. Okay, and all of this is divided by the payment. And my payment was $1,000. So we have to take the ln of that divided by, and now we're going to be dividing by the ln of 1 plus, all right, and now we have 0.1 divided by 12. So this is going to be a pain in the behind to try to put into our calculators. All right, so let's take a look and see how we can do that. So I'm going to take out a regular calculator here. Let me swing it over to the other side and show you how you can input that in. So I'm going to first, okay, actually work with the brackets, okay, so taking the ln of that entire junk right there. So we're going to try to figure out what that is. All right, so let's work through it. So I have 1 plus, okay, so now it is 1 million, so it is 1 million times 0.1, all right, and divided by 12. So what I'm doing right now is I am just calculating. Let me swing this back, open it back up there, change the color. So I'm just inputting this in here. So that's what I have. So that equals, and now that is divided by 1,000. So notice 1,000. So I'm going to take my answer divided by 1,000. All right, equals to that. And then plus the 1. Let's not forget that. So that's answer plus 1. All right. So I have basically 9.33333 on top. And now I need to take ln of that. So I have to take the ln of that answer. So I'm going to take, So let me clear this. So this is now ln, okay, of that answer, 9.333333 and so on. So put as many as you can in there, and there you have it. So I have now found what my numerator is. All right, so that is my numerator. Now, some people will kind of write this down for themselves, and you want to try to do it with as many decimals as you can, and then they're going to divide by the denominator, so 1 plus 0.1 divided by 12. Now, because I already have that answer in my calculator, I don't really have to write it down. I will just take my answer and then say divided by, okay, so the ln of, and inside of that bracket, I have 1 plus 0.1 divided by 12, close the bracket. All right, so that's what I would have had in there. And I'm just looking there. Yep, all right, so let's just make sure the brackets align and equals, and this is what we would have. So that's our answer overall. So n is equal to 269.146 and so on. So this brings about an interesting thing, because how do we round? Remember, n is the number of terms or number of payments. And we can't really have 0.146 payments and so on. So we assume, okay, on the business side, that we always pretty much round up. Okay, because 269 payments will not get you to that future value. You're still going to have to make some partial payment at the end. It might be smaller than your $1,000, but okay, it's going to have an additional n. So our answer would actually be 270. And I know that you might say, well, it's 0.1. Shouldn't you be rounding down? Okay, it's just by convention that we typically round up the number of terms. Because if we round down, then we never got to, okay, the actual accumulated value that we wanted. All right. And now the other part of this is they did ask us in the question. So notice, I'm going to keep this in the calculator there. They asked us in the question how many years this is, right? How many years? But what we have been doing is we have found the number of months because it was monthly. So the 270 or 269, so this right here, so our answer is actually in months, right? So we would have to take this answer and actually divide it. So we would divide it by 12, all right? And now let me clear this because we rounded it, so it would be 270 divided by 12. So it would take approximately 22.5 years. That's how long it would take us, 22.5 years to be a millionaire, right? If you're putting away about, okay, $1,000 a month, and you're lucky enough to get a 10% compounded interest, which I'm sure a lot of people would love to have. I certainly would. So that's it's not an easy thing to do. Okay, so that's how long it would take you. So this was a great example. Now, what I want to show you is putting this in to the calculator. Even if you're good with calculators, it's a little painful. Never mind a little painful. It's actually quite painful to do it. So I'm just going to move kind of this stuff out of the way here on my desk. And I want to show you, okay, how to do it with a business calculator. All right, and we'll see what we're going to get. So I'm going to just share with you. All right, so here's the business calculator, and we're going to try to input everything in that we had. So on your business calculator, which by the way, I highly encourage that you actually use, okay, so the business calculators, for these types of problems. So first off, by now, if you've watched the previous lessons, you should know. So first, let's set, okay, our payments. Okay, great. It's 12 already. Okay, so it's 12. Perfect. So it's already set up, right? Because we're compounding monthly. So that's why it's 12. If it was something else, we would have to change it. So I just wanted to change that. All right, so let me do that. And now let's try to input it in because we're solving for n right here, but we don't have it yet. So now so I was 10%, right? So that's I. Remember, we put it as a interest and we don't divide by 12 because we already put payments and compounding periods as 12. So the calculator does it for us. Now the payments, okay, so the present value, so present value is 0 for this. We didn't start with anything. Now our payments and future value. Here is a comment. By convention, right, what we do is in our business calculators with these BA2 analysts, we always have payments and future value. So one has to be positive, one has to be negative. All right. And it should kind of make sense because, for example, if you are parting with money, so if you are giving money away, and in this case, we're investing money. So we're technically kind of losing that money each month. We probably should make the payment negative, right? So that's what I'm going to do. I'm going to say we have our payment, okay, which is negative, meaning we're investing money. So that's our payment. And the future value should be positive. So that's something when you're inputting, do not input payment and future value to be of the same sign because you're going to get the wrong answer on your analyst. All right. So now for the future value, we wanted a million. I apologize. That's million right there. So that's future value. All right. And now we can compute. So compute N. That's what we wanted to do. And notice we get exactly the same thing, right? So if I go back here to our notes, all right, okay, notice that this is exactly what we got, which was 269.14 and so on. And that is way easier. If you're going to do annuities and you're not using a business analyst, you're either stubborn or I'm not sure what it is. I know that I'm actually coming from not the business world side. I'm coming more from the kind of more applied science, okay, engineering and so on. But I've stumbled into investing and I've started something on my own. So I've fallen in love with this type of math, and I surely appreciate the business analyst because it does a lot of things for us. So that was this example. I hope you found it useful. Let's do one more example. So here it is, and this one will be with, okay, the actual present value. So this will be a good one to know. And for this example, instead of inputting it into the calculator with our formulas, okay, so it would have been this formula right here. That would be annoying. We're going to use our business analyst right away. And you'll see that you can solve it so much faster. All right, so here, let's take a look. Okay, so at the example, and let's write down the givens. So if you borrowed, so notice borrowed $250,000, so 250,000. So that is present value, and had to repay the loan in payments of 4,000 each quarter. Then how many years would it take you to repay the loan? All right, that's the question. Now assume that time value of money is 2.1% compounded quarterly. So time value of money, you should know what that means, okay, from compounding. All right, so keep that in mind. Okay, maybe I'll put a link up above into the compounding playlist if you're interested. All right, so now let's write these down. So I'm going to write it all down. So here are my givens. So in this case, I know my present value. So that is 250,000. I know my payments. So my payments are $4,000. They're asking me for how many years. Okay, in this case, I know my interest. So my interest is 2.1%. And notice that your payments per year are equal to your compounding per year. So notice those are quarterly right here and compounded quarterly. So we need that for the simple annuities, right? Okay, so that's what we have there. So it's quarterly, so this is equal to 4. And now we're supposed to find the n. Now, keep in mind, the n we find is the number of payments, right? So how many terms? So if they want the number of years, we're going to have to change it back, okay, into years for ourselves. All right. So let's take a look. And again, I'm going to, all right, so I'm going to switch back to the camera view so that you can see it. And here it is. All right. So here was our last example. So let's clear this off. All right. I'm going to say second function. So clear time value of money. Okay. So see, I'll clear TVM. So just let me clear all of this. Now let me input. So it's obviously not 12 because it's quarterly. So let's enter that. Make sure that that updated. Okay, so that's updated there. All right, let me exit here. And now let's try to fire them in. Okay, so our interest, right? So our interest was, actually I forget, I'm sorry. So it's 2.1. Okay, so that was our interest. So here is, so 2.1. All right, so that's our interest right there. Okay, so that's that. Our present value. So again, remember that in this case, okay, the present value and your payment must have different signs. Now, whatever sign convention you choose is up to you. All right, so, you know, I always think money coming to me is positive. Money coming out of me, meaning I have to pay them, is negative. So that's kind of how I think. So I borrowed money, so they gave me money. So that for me, that would be positive. So I'm going to put, okay, my present value, so 250,000 as positive. So that's my present value. All right. My payments, I have to pay those payments. So I'm making payments of $4,000. So $4,000, and I'm making them, so I'm going to make them negative. So that's payment right there. There is no future value, right? So that's 0. Okay, it'll be that. And now we want to compute. So hit compute and there you have it. So it's 75.94 and so on. So the same thing, because it's the number of terms, right? Number of payments, we always will be rounding up. So this would be 76. So we can put that in here. Let me go back. All right, so this is what we would have. So the number of terms, okay, would have been 76 terms or payments, all right, that you would have had. Now, these payments were coming in quarters, right? So if you want to find out how many years this was, you basically have to divide this by 4 because there are 4 quarters in every year. So, you know, we can do that. So 76 divided by 4 will tell you that this would take you about 19 years to pay off. All right. And this is why, you know, when a lot of people borrow money for mortgages and so on, okay, so those concepts kind of translate back. And that's why it takes quite a while to, you know, to pay off a mortgage. So here, to finally answer this, you know, how long it would have took, it would have taken about 19 years. All right. Okay, so that's that example. So things to keep in mind, okay, when you're entering this in, because we didn't really run into this problem in the previous lessons. You know, so now in this lesson, it is. Because before we didn't have payments and present value or payments and future value. Right? Now we have them. So keep in mind that you have to enter. So if you are using, so note, if you use the BA2 plus, okay, so business calculator, make sure you know, okay, that if you're going to be entering present value and payments, all right, they have to have opposite signs. All right, so opposite signs. And the same thing is if you're going to be entering future value and payments. All right, so they must have. And again, I think of it as money coming to me, positive, money coming out of me, negative. All right, so if I borrow money, all right, so they gave me money, I have more, okay, and then I'm paying the payments, so that would be negative. All right, now if I'm investing, then I guess I am putting money in, so that's money I'm losing, right? So that would be negative. And then at the end of the road, you know, that $1 million in that previous example, that future value would be positive because then it's all coming back to me. All right, of course, compounded. All right, so thanks for watching. I hope you found these examples useful, and I hope that you can try them on your own. All right, okay, so bye, and we'll see you in a future video. Okay, take care, everybody. Cheers.